We're live? Oh yeah, hi, welcome to Science with Mike. My name's Mike. I've been teaching here at Sinclair for 23 years. And a little bit about myself, I just wrecked my bike an hour ago. And that's why I got this. And I'm a little bit not myself, so please forgive me. So first, what I'm going to do, also not myself, is ask you guys, because we've got our studio audience here. Thank you for coming, both of you. And yeah, oh, sounded like 8. So, do you guys like magic?
Yes, we love magic.
It's too bad because it's all fake. Anyhow, what's going to happen here is I'm going to start with a magic trick, and Kyle is going to prove to me that we're going to take these cups, and I just want you to look in here, Kyle, and see that these are just regular old cups, right?
Regular
Nothing
cups.
in there, just regular cups, nothing in there at all. That would be fake if there was, just completely empty. Not going to turn them upside down, but what I'm going to do is I'm going to take one of the cups. Now, Kyle, I want you, I don't know why we needed that one, to pay attention to which one I put the water in. Pay attention, okay? And now what I'm going to do is I'm going to mix the cups around and then say a magic word, okay? So, pay attention to, okay, and all you folks too, pay attention to where the cup goes. Now I'm going to make a fake magic word, and I'm going to say Avogadro. And so where is the cup with the water in it? On the left? This one here? This one? So if I poured it out, it would pour out. But it didn't pour out. Why? Fake magic. So this must be the one with the water, and I did some sort of strange thing, but then that doesn't have the water in it. So I'm going to take this water and I'm going to pour it on my head there's no water anywhere. It all disappeared. Where'd it go? Magic, right? Magic, magic. No magic. There's no magic. It's science. Because what happened is I put something in this cup. That's why I didn't. It had sodium polyacrylate in it. Now, one of the themes of what we're doing today is ions and water. And ions are charged particles. This has sodium ion in it. It's a polymer. I'll show you what it is because I've been hiding it back here as I limp painfully over here. Let me show you. This is an ounce of sodium polyacrylate. Here's the bottle I was hiding. And it also has the sort of trade name as a Waterlock polymer. So what I'm going to do is take this big old beaker and I'm going to pour 28.3 grams, an ounce. It has a lot of volume, doesn't it, for an ounce? And so we're going to throw that in here. And I'm going to show you what happens when we put some water in there. All right? So take a little bit of water. And what happens is there's repeating units of carbons with sodium ions. And the sodium ions, if I can write it out, sodium ion, Na+, that's a charged particle, and it likes the water molecules. Water molecules are charged as well, and so they have an attraction for each other. This is going to hold on to the water. How much more do you think it'll take? That ain't doing, right? How much more you folks think it'll take? A little bit more? All right, let's try that. All right, let's try a lot more. Let's get some water from here, all right? So, I need that water for later. Take a lot more here. All right. It's getting there, right? But this stuff is actually supposed to be able to take like up to 100 to 200 times its mass in water and kind of freeze it there. So there you go. It's just getting to the capacity where it can't hold it anymore. But you wait, it'll hold on to it after a while. And so that is our first little demonstration. Sodium polyacrylate ions clinging to water. All right? So any questions from anybody? We're not turning to the internet. Yes, question?
What is that substance found in everything?
Ooh, now I have a feeling you're a mom because you probably know what it's used in. But diapers, right? So diapers, all kinds of diapers, you know, for kids and people who want to play a lot of video games all in one sitting. Hair gel, it's used in. And so there you go. It's called water lock. And actually, you see, it's kind of, it's getting there, but it's probably held on to about, what, 1,700 milliliters there. So that's sodium polyacrylate, folks. And our next thing we're going to do is talk about electrolytes. So, that's not anything. Okay. Electrolytes. We've all heard of electrolytes, right? You need them in your body. What are electrolytes? Well, I'm going to ask you a trick question. I'm going to try to trick you folks as much as possible. So if I can say thank you, lovely assistant, I'm going to go ahead and take some water. This is just water. Let me ask you trick question number 1. Is water a good conductor of electricity? No? Yes? Anybody say yes? Okay, I said it was a trick question. People say no. Okay. You would think, but so then you should just go in the swimming pool when it's lightning outside, right? But no, not at all. The trick question was that this is pure water. So this is pure water, and now what I'm going to do, just to show you folks, that if I take and bridge these 2 points, these electrodes, it's going to, not just see, wood, had you going there. Trick number 2, wood, not conducting, all right? And now what will happen is that'll light up this light bulb. So what we're going to do is we're going to compare this water and tap water. Okay. This is right out of the tap. That's why I'm getting it, to show you that it's right out of the tap. And now I probably should wear my safety glasses. I'm not myself today, folks. Here, which one was what? This is the water. Nothing. All right. And would one of my lovely assistants douse the light a little bit, maybe half of them, something like that? Here's tap water. Little bit of something. Can you tell? Little bit of something. All right. Maybe douse it a little more. All of them, maybe. There you go. Aha. A little bit of something. Back to the pure water. Nothing. Back to tap water. Little bit of something. Okay? So, why little bit of something? Because tap water has, okay, with the lights, thank you. Tap water has electrolytes in it. You know, you got calcium in there. If you have hard water, if you have a water softener, you're taking the calcium ions out and you're putting in sodium ions. And so what I want to show you next is that if I take a little bit of an electrolyte, salt, it makes ions. And so we'll just take a little bit. That's what we call in science a measure some out real carefully there. Okay? And give it a little stir. That's what we call in science stirring it around a little bit. Okay? And now, lovely assistant, no, we don't even need that light because you can see that the light is illuminated pretty well. Matter of fact, let's do something else different here. Let's take a little bit of Gatorade, or I said that energy drink, I should say, and don't want to give anybody free advertising. So here is some. You know that you drink this because you want to get electrolytes, and so this is blue Gatorade, okay? And if you do it with orange, same thing. Same exact thing as yellow. Sure. Okay, same exact thing, the electrolytes doing the conducting. Matter of fact, let's do this. I hope no one's going to drink this. I don't think this was here for drinking purposes. But let's try some of what I've got over here is a pickle from an unknown source. All right. And we have pickle juice, right? Because one of my lovely assistants blocked out the name on it. It's not from any mountain where they get olives or anything. All right. Pickle juice. Next. Whole bunch of something. Huh? All right. Next, I have a job for the pickle cuter. Pickle cuter. SCC1, ladies and gentlemen. And that is where I might need my lovely assistant to grab that for me. No, it's fine. Thank you, Kimberly. Grab it and maybe plug it in, but don't touch it. Because, oh, no, don't plug it in. Don't plug it in. This is the Pickle Cuter SCC1. And you might look at it and say, Mike, isn't that just an extension cord that's been rewired to 2 rusty nails on a board? If you want to look at it that way, it is. All right. But what we're going to do next is we are going to pass 120 volts of alternating current. Oh, no, this is my worst nightmare. Now I got to reach in and get it. Okay, so anyhow, that's how much I love science. Is that I'm handling pickles. And now I will need, what do you think is going to happen? Pickle juice in there, right? What do you think is going to happen? I'm going to pass electricity through there. And it's going to conduct a current because there's a lot of these ions and moving particles conduct electricity. So now we're going to douse all the lights again to my lovely assistant Kimberly and watch in awe as the Pickle Cuter SCC1 passes electrolytes, passes current through the pickle. That yellow you see, that is the excitation of sodium. All elements have different colors when they're excited, and the color of sodium is yellow. And so there's a lot of salt in pickle juice. And you'd think I was going to shut it off right about now. Nope. Going to keep it going just to see how much it's got in it. Both the Pickle Cuter SCC1 and the pickle itself. Maybe while we're zapping the pickle, we could field some questions from our internet folks, if anybody's got any.
We have a question back
Yeah,
here.
yeah.
So this demonstration with the Pickle Cuter SCC1,
Yes.
this is what we would look like if we tried to enjoy fresh toast in the bathtub?
Yes, this is, question was, is this similar to what you'd look like if you put a toaster in the bathtub? And probably, I don't know if you'd glow just yellow. You might glow all different. You have more than just a lot of sodium in you. We're more diverse as organisms than a pickle. Which, by the way, what vegetable is a pickle? Anybody? What vegetable is a pickle?
Cucumber.
Okay, trick question. It's a fruit. Gotcha. Sorry, I did it to my lovely assistant. And now you see we're drying out of electrolyte. And so my lovely assistant, if we can bring the lights back up, and we're making you multitask. Okay, questions from the internet world?
Well, the question we have back here is,
Yes.
what does the pickle smell like now?
What does the pickle smell like now? Oh, if it's a question from back there, let me just give it to you.
No, we're feeling the
It has a hint of smoky kind of, smells like shame. Actually, just shameful. Shameful electrocuted pickle. That's what it smells like. All right. Anybody burning with questions out there? Maybe move on to the next thing or no?
Let's move on to the next thing.
Save the question for later? Okay, sorry, person, whoever you are. Next, I have a real treat for you. And I don't know how close in we're going to be able to get on this, but what I'm going to do next is take and talk about potassium. Where do you find potassium? Anybody? Potassium is in what? Bananas. There you go. As he's got that Science with Mike banana shirt on. And the banana people, that's what we should call them. Yes, you have potassium in bananas. And so what I have, though, is some elemental potassium. I don't know if we'll be able to get, and you know what? I'm going to let Addie help me with this one because it's exciting. I'm going to let you throw into water some potassium. Let me do a good cut on it, and I don't know if we can get it close in, guys, but if we can, that'd be great. But if not, I'll try to tilt the camera or tilt this towards the camera. That is a big old hunk of potassium. Now, it is not potassium that's in bananas. The potassium that's in bananas is potassium ion, all right? That's the charged particle, and that's what happens after a potassium elemental atom loses an electron, all right? This is stable, and you can have it, and you have it in your cells. This is super unstable, and we're going to finish our kind of experiments here today by cutting open a piece. This is very dangerous. You probably can't get your hands on potassium anyway, but what it'll do is it'll make hydrogen gas, and that is, as we've seen last week, which is, I think, what scared all our audience off, is that hydrogen gas is that's pretty shiny, all right? And it actually cuts like butter, all right? And what I'm going to do is I'm going to have Addie help me. This is a huge hunk of potassium, more so than we probably should be doing. But then what I'm going to do is if you take that piece, quickly throw it in the water, but not yet because I got to get a watch glass, and then we're going to cover it so no pieces can fly out and hit Kyle. Kristen is back there. She's probably not within range. Okay, ready? Go. All right, so what you're seeing there, and you probably can't see it because all that's burn up mineral oil. That's what we have to store it in. We have to actually store potassium in mineral oil, so that's just smoke, really. And what you might have seen is a little bit of a purple flame. That one was a bit of a dud. I'll try to cut the center out of the next one. And the purple flame is the hydrogen. It's actually a little bit of the potassium, too, makes a violet. Remember how sodium was yellow, and the violet is the color of potassium. So let's do another one. This one I'm going to trim up better, and then we'll see what the internet has to say. And then, I don't know, folks. I'm rolling right along here. That's all I got for you after this. So, big old piece. Just cut the... It had a lot of the yellow oxide on it. That's all just metal right there. Okay, Addie, let's have you, same drill, use a different, that's salt. Nah, same drill. Okay, here we go. There you go. Yeah, that's burning mineral oil, and then the purple was the hydrogen there. So. And then you might say, well, how do you get rid of it? You know, it's real easy. You just throw the rest of it all in there. And then how do you get rid of it off your knife and stuff? You run it over water and sparks come flying out. It's glorious. And so there you go. Let's get rid of the rest of it, too. Questions? I fell off my bike. Yes?
Are there other elements that will do that kind of thing?
Oh, yeah. Actually, let me point to the group of elements that do all of that, okay? What we saw is potassium here, all right? And so if you go down in this family, the atoms get bigger and the electrons come off easier, which makes them all more and more reactive. Rubidium, can't even get it. Yeah, I doubt you could store it. Cesium, super reactive. It's actually more expensive than gold. So you can see why you don't find on YouTube everybody throwing cesium into stuff, I guess. Sodium will do that, lithium, all those elements in that family called the alkali metals. And actually, if you tested this is a very alkaline solution now that we've created. So it's been, pardon me not being myself, I hit a drain, did an endo on my bike on 4th Street. No worries, it's all good, Dayton. We'll watch it for it next time. Questions from anybody? No questions? Yeah.
Isn't there something about electrolytes having radical electrons?
Radical electrons? Sounds like some sort of protest or something. You can make like a carbocation, are you talking about? Well, I mean, you can make an ion out of anything that doesn't normally make an ion. You could put charged plates in amongst argon and you can ionize it. So, but this happens passively because of something called the octet rule. The octet rule is that everything wants to have as many electrons generally as the noble gas atoms, and that's why this happens passively. But actively, you can make anything ionized. And that's a different day when I don't fall off my bike, maybe. Yes?
What would you say were the funnier elements?
The funnier elements? I thought that was pretty funny. And you guys think it was funny? I thought potassium was funny. Yeah. So, all right. I'm not sure that we're connecting with the folks who have been watching online, but I think I'm about ready to wrap it up here, folks. So anybody have any questions? No? It's okay. There's always, that first show was crazy. This is a little bit more subdued today, and I fell off my bike and hardly can walk. So thank you for watching Science with Mike, everybody. And remember, science is really important, and there's no magic. Magic, fake, all fake. Sorry. I didn't mean to bum you out, but just applied science was our magic. So I need an ice pack.